Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. Today our new topic is the exponential function. The function in which the independent variable used in exponents in the power. For example, this is y is equal to b raised to the power x, where y is dependent variable and x is independent variable and b is base of this exponential function, a common base. In here x is a play the role in exponents. Such type of functions where the x used in exponent, such functions are called exponential functions, where x is in exponent, that is power, and b is base of the function. Types of exponential function: the first one, growth processes are increasing function, the function in which as the value of x increase and y also increase in the same direction, that is called growth processes exponential function. But condition for this exponential function is this, that b should not be equal to 0, mean base value should not be equal to 0. Base value should not be equal to 1 and base b must be greater than 1. Why? What is the reason? Because if we are putting b is equal to 0 in here, means in this growth processes function, if the value of b is 0, so 0 raised to the power 1 million is equal to 0. It's not increasing. So how we can say this is increasing function? Again, b should not be equal to 1, because if we again put here in place of b1 and it raised to the power 1 billion, it will be 1. So that is why this is not increasing, and we put the condition that for the growth processes exponential function, the value of base should not be 0, should not be 1, and this must be greater than 1. When this will be greater than 1, as we will increase the x values, y will automatically increase. For example, y is equal to 2 raised to the power x. When we assign values to x, we will find y. As we will increase x, y will automatically increase. Y is equal to 2.5 raised to the power x. Again, this is increasing function. As we will assign values to x, we will find the value of y. As x will increase, y will also increase in the same direction. It means that the increasing exponential function in both variables, there is positive relationship. When x will increase, y will also increase, and when x will decrease, y will also decrease. But condition is this, that the base value b must be greater than 1. Now we are proceeding toward the decay processes function or decrease processes function, the function in which the values of y will fall as the value of y will rises as x decreases, or the value of y will decrease as x increase, means negative relationship between the x and y. If we increase x in this decay function, y will decrease. If we decrease x, y will increase, inverse relationship. But condition is this, b should not be equal to 0, b should not be equal to 1, but b must be between 0 and 1. b should be greater than 0 and less than 1. Like for example 0.1, 0.5, 0.7, 0.9. So when the value of the b will be greater than 0 and less than 1, this function is called decreasing function. As we will increase the x, y will decrease, or as we decrease the x, y will increase. For example, this is y is equal to 0.5 raised to the power x. This is mental math. You can check at home, assign values to x and solve for y. As you will increase x, y will definitely decrease. I put here one short note. This is a mental math. You can solve at home. Note, assign values to x and find the increasing and decreasing results of y respectively. Respectively mean with tartib. First you have to increase the value of x, so y will decrease, or if you decrease the value of x, y will increase. So assign values at home to these exponential function and solve for y. Now we are proceeding toward the base e exponential functions, those functions in which The base of the exponential function is e, where e is a constant value. This is fitted in the calculator that e is equal to 2.71828, where e is a constant value. And the mathematical notation of this e exponential function, y is equal to e raised to the power x. Again, x is the independent variable which is used in exponent. Y is the dependent variable. E is the base of this exponential function, where a and m are any constant values. Now we are coming toward the applications of the base e exponential functions. So growth processes base e exponential functions are used to measure, to estimate increase in the value of capital assets, increase in population, increase in the value of account, increase in the usage of energy over time, increase in the value of currency over time. So it's mean this is the practical application of the base e exponential functions, that base e exponential function help us to measure, to estimate, to calculate increase over time at a constant rate in the value of the capital assets like building, machinery, equipment, car, truck, etc., etc. These are all capital, and its value increase over time at a constant rate. We can calculate the increase in the value of capital assets, increase in population, increase in the usage of energy over time, increase in the value of Afghani rupee over time. We can compute using growth processes base e exponential functions. This is actually the growth process base e exponential function standard form. V is equal to V0 e raised to the power kt. This is explained below here, where V0 is initial purchase value of the capital assets. V0 represent initial price of the machine or the building or any capital assets that one purchased. V0 initial value, purchase value. T, you know, that is the time period for which the company is using machine or capital asset, where K is the constant growth rate in percentages of the capital asset over time. The constant growth rate in values of the capital asset in percentages. The value of the machine, the value of the building, the value of the car is increasing at a constant rate K over time. That K represent that percentage growth in the value of the capital assets. And E, you know, that is a constant value. E is equal to 2.71828, and V is actually the value of this machine, this capital assets, this building, this office, this house, after using this machine, this capital assets for the time T periods. So V is the value of the machine, of the capital assets after time T period, after T number of years. So this is the description of this standard form. V is equal to V0 e raised to the power kt. I am again repeating V. V is actually the value of the capital assets after using the assets for the T number of years. V0 is the initial value of that capital assets. K is the percentage growth rate over time of the capital assets. T, the number of years for which you use the machine or the capital assets. Now we are putting one example. If one purchased machine at price $1 lakh in 2015, the values of the machines increase at 4% growth rate annually. What is the value of this machine after 5 years? So we have to find the value V after 5 years. V0 initial value is already mentioned, $1 lakh, and T is the 5 years. Calculate the value of this machine after 5 years, and the growth rate in percentages is given, that is 4%. It's annually the value of this capital assets 4% increase every year. Put these values in the growth process function. This is the function. V is equal to V0 e raised to the power kt. V is equal to V0 is 1 lakh, e raised to the power time is 5, percentage growth rate is 0.04, 5 multiplied by 0.04 is equal to 0.2, and you can use the scientific calculator to calculate the value e raised to the power 0.2 यानी e बतावाने 0.2 you can calculate using calculator. Now we are this is the final value of this machine after 5 years, which is you can say 1,22,140 rupees. It's mean the purchase value was 1 lakh, and now this is 1,22,140. So it's mean over time this value increase. Now we are switching toward the base e exponential function. The function in which the base is a 2.7, e is base e is a 2.71828, where e is a constant value. And again the same examples I repeat, where a and m are any constant values, and in here we are using the applications of the base e exponential function second type of base e exponential function, which is decay or decrease processes base e exponential function. Before this that we discussed that were growth processes exponential function, and now this one that is decay or decrease processes base e exponential function. So decay processes exponential function is also used to compute, to measure, to estimate decrease in the value of the capital assets over time. For example, decrease in population, decrease in the value of machine, decrease in the value of your account, decrease in the value of currency of Afghanistan, decrease in the usage of energy, oil, electricity over time. So decay processes function or decreasing processes function we can use to calculate decrease in value of the different variables. So again the standard formula for this decay exponential function is here given. V is equal to V0 e raised to the power minus kt. The same interpretation, the only difference is here that k is negative. Slope of this exponential function, that is negative, the growth rate is actually decreasing minus k, and it decrease in percentages in the value of assets, in population, in inflation, etc., etc. So we again repeat, V0 initial purchase value of the assets, V is the value of the capital assets after time period, after the usage of the assets, K is the constant decrease rate in percentages, and E is a constant value 2.71828, and T is the time period for which the company or any individual is utilizing the available capital asset. For example, if one purchase a car at a price of $10,000 in 2018, the value of the machine decreased at a 2% annually. What is the value of this machine after 10 years? Again, value after 10 years we have to compute. V0 is $10,000, time is 10 years, and the decrease in the value of asset per year, that is 2%. Put these values in the growth processes function. V is equal to V0 e raised to the power minus kt. Again, this is very easy. Student can solve at home. The informations are already given. T is also known, 10 years. K is also known, 2%. V0 is also known. E is also known. The value of E is a 2.71828. When we substitute these values, $10,000 e raised to the power minus 0.02, that is percentage decrease in value of the capital asset, and time is 10 years. So when we multiply the 10 year with 0.02, we find e raised to the power minus 0.2. And when we manipulate using calculator, so we find out the final value after 10 years of the capital asset, 818730.75. So value of the asset decrease over time. I am again repeating, one purchased a car at a price of $10,000 in 18. The values of the machine decreased 2% annually. What is the value of this machine after passing 10 years? V0 is $10,000, T is 10 years, and K decrease is a 2% annually. Put these values in the decay processes function. Sorry, this is not growth processes. This is typing mistake. This is not growth process function. We are discussing decay process function. So change this, students. I am again repeating, this is not growth process function. This is decay process function. The difference between growth process and decay process is this, that in the growth process this K is positive, and in the decay decrease processes this is negative. We put the value V0 is given $10,000, time is given 10 years, K is 2%. When we multiply e raised to the power minus 0.2, so minus 0. E raised to the power minus 0.2 you can find out from the calculator. Whatever you find, directly multiply with $10,000. So value after 10,000 after 10 years of the car is 8,18,730.75. Now we are coming toward the logarithmic functions. Logarithm is the power to which a base raised to yield a particular number. In a logarithm is the power to which any particular base will raise to give us a particular number. For example, y is equal to b raised to the power x. This is exponential function. In here, this x is actually the logarithm of the number y to which the base b will raise, where y is the particular number, b is base, and x is the logarithm of the number y. Write logarithmic function as exponential functions. These are exponential functions. Y is equal to b raised to the power x. The base is a common base b. So x is the logarithm. We define that power is the logarithm. Here x is in power. We define logarithm is the power to which any base raised to give a number. So in here in the power we have x. Its mean logarithm is x. And to this x, this base b is raising, and when this raise, it will give the number y. So y is equal to b raised to the power x. This is exponential function. The exponent x is logarithm of the number y with a base b. Its mean this base b will raise to the exponent x, and we will as a result find the number y. How we can change this to the logarithmic form? Its mean x is the logarithm of the number y if the base is b. Again, I am putting here specific example. 100 is equal to 10 raised to the power 2. So 2 in the exponent. Power is the logarithm. Power is the logarithm. Logarithm of what? Logarithm of this number 100 if the base is 10. So we can write that 2 is the logarithm of the 100 when the base is 10. And you know when 10 raised to the power 2, we will find 100. Again, 10,000 is equal to 10 raised to the power 4. Again, I am repeating that exponent power is the logarithm, and to which a base 10 raise and yield give us the number 10,000. So, we will write 4 is the log of the number 10,000 if the base is 10. 4 is the logarithm of 10,000 if the base is 10. Now we are defining the different types of logarithmic functions. The first one, common logarithmic function. The common logarithmic function carry the base 10. This is the most commonly used logarithm. The most commonly used logarithm is a common logarithm, and its base is always 10. For example, log with the base 10 of number 100 is equal to 2. Its mean 2 is the logarithm of the number 100 if the base is 10, where logarithm of the 100 is 2, to which the 10 raised to give the number 100, where 2 is the logarithm of this 100 number, and to this 2 power logarithm, this when this 10 raised the base raise, it will give us the number 100. So I write where logarithm of the 100 number is 2, to this 2 if 10 raised, it will give us the 100 number 100. Now the second one, natural logarithmic function. When in the natural logarithmic function base is e. This is a natural logarithmic function, its base is e, and it is used to solve the applied base exponential functions, base e exponential functions, base e exponential equation. In a natural logarithmic function where base is e, we are using to solve base e exponential equations, base e exponential functions. Mathematical notation of the natural logarithmic function with the base e is this: y is equal to natural log x, where e does not write but it exists. In here base e exists but we are not writing. I'm again repeating, y is equal to natural log x, e exists in here but we are not writing. Conversion to the base e exponential functions. Suppose we have the exponential function but its base is not e, it is a common base, something else other than e. We have the exponential function but the exponential function base is not e, this is other than e, any number, or you can say a standard form b. B is the base of this exponential function. It can be 10, it can be 2, it can be 3, it can be any number. So how to convert this base b or any base, any number to the base e exponential function, because we need base e exponential function. I'm again repeating, conversion to the base e exponential functions, and here we will learn how to change the exponential functions with a common base b. We will change given base b to such an expression with the base e and some exponent n is given. B is equal to e raised to the power n. In this process, we are going to change the common base exponential function to the base e exponential function. So what is the procedure? What is the methodology? We will change the given base, which is not e, which is other than e. We will change this to another expression where the base is e and power is some number, maybe x or n, that is a symbol, but this x or n will definitely carry some value because we are just generalizing that I am changing the common base b to the exponential base e. So what is the methodology? We will change the given base b, which is any number, to another expression which base is e and carry some power, and we are using a symbol n for that power as this is given here. B is the common base. I'm changing this to this expression e raised to the power n. I'm telling you, I'm forcing that students that how to change base b exponential function to base e exponential function. Methodology is this, that we will search for another expression where the base must be e and having some power. So this b is equal to the e with power n, and we will replace this e raised to the power n for this b in the exponential function which base is not e, and automatically it will change to the base e exponential function. For example, y is equal to 3 raised to the power x. Now in here this is exponential function but base is not e. This base is a 3, as this is clear. This is not e. This is 3. Now we need exponential function with a base e, not 3. So how to solve this problem? We need actually base e, not 3. So let's change 3 to such an expression which base with base e like this. Suppose 3 is equal to e raised to the power 1.1. If I am writing e raised to the power 1.1, calculate, you have the scientific calculator, e raised to the power 1.1 will give closed value or exact 3 value. So it's mean e raised to the power 1.1 is equal to 3, and I need base e exponential function, so I can replace e raised to the power 1.1 for this 3 in this given exponential function. Substitute e raised to the power 1.1 for 3 in the function as given. Y is equal to e raised to the power 1.1 whole power x. When we multiply, we will find y is equal to e raised to the power 1.1 zarab x, and now we change this base b exponential function to base e exponential function. Now the base of this function is e. I am again repeating that conversion to the base e exponential function. Suppose we need base e exponential function to solve our mathematical problem, but in here the exponential function carry base other than e, like b, like 10, like 3, like 50. Now what to do? We will search for another expression which carry base e. For example, here 3 is the base, and I search from the book that e raised to the power 1.1 is equal to 3. You can check using your scientific calculator. Take e raised to the power 1.1, it will give you 3 values. So it's mean 3 is equal to e raised to the power 1.1, and we can replace in this base b exponential function, base 3 exponential function, we can replace here the value of e raised to the power 1.1. So as I replace, we change the base 3 exponential function to the base e exponential function, and this is we call conversion to the base e exponential function. Now properties of the logarithmic function. Look, this is log having two functions. Under the log we have two functions, one is u and other is v, is equal to log of the first function u plus log of the second function v. By taking log of the first function u and plus taking again log of the second function v respectively, this is the logarithmic function properties to solve the logarithmic function when the functions are in multiplication form under the log. I am again repeating first property of the logarithmic function when two functions are under the log. So how to solve this problem? We will take separately one by one log of both function, as I am applying here log of the first function u plus log of the second function v. We will take respectively with tertib log of the first function plus sign log of the second function. Another property, log of the two function in division form, log of u divided by v. So we will solve log of the first function u minus log of the second function v, log of first function minus log of second function. Here again I am repeating that we have two functions under the log, but both functions are in division form. So to solve this problem, we will take the log of first function u, negative sign the log of second function v. The third property, log x raised to the power n. We will take the n in the exponent, take n from the exponent to the coefficient of the log, and this is the way to solve. Take the power down to the coefficient. Solve logarithmic function. For example, log of x square plus 2x is equal to 20. This is one logarithmic function. Natural log is involved. We can change this logarithmic function the base e exponential function. In here, base of this natural log is e. So we can change this natural logarithmic function to the base e exponential function to solve our mathematical problem. Write as a base e exponential function. So I am writing this 20 is actually the power, 20 is actually the logarithm. 20 is the logarithm of the function x square plus 2x if the base is e. So we can write that e raised to the power 20, e raised to the power 20 is equal to x square plus 2x. Here this is the exponent and base is e, and this is your number, or you can say your expression. So we can write in base e exponential function e raised to the power 20 will give us this expression. Now e raised to the power 20 is 485, 165, 195.40 is equal to x square plus 2x, and further we can solve this using quadratic formula or factorization method to find out the x values.